Hello! In this video, I'll be presenting a prototype I've been working on lately. It's a programming environment whose goal is to let you design and perform temporal scenarios of live shows and art installations. So, for instance, let's say you have a live show with musicians and dancers, and you also have sound or video tracks, stage lights, perhaps you have generative audio or shaders, you name it. And of course, you want all of these to be synchronized and follow some kind of scenario. Furthermore, you may want this scenario to be paced to follow human performers, or you may want an open scenario with multiple choices, or you may even want the audience to interact with the course of the show. So you need tools to let you plan and control that kind of things. I think these tools face a number of requirements that can be somewhat contradictory. For instance, you want a tool that lets you encode and perform complex processes with very precise control, but you also want a tool that's easy to use and easy to tweak during creation and rehearsals, and that's also really easy to monitor and interact with during the show. And that's really important because you need to quickly understand what is happening live and have ways of steering the scenario to adapt to the unpredictable variations of each performance. So I've been exploring that problem space for a little while, and I found that I really wanted to target quite technical users and give them the full expressive power of a temporal programming language. But at the same time, the traditional way we program isn't really well suited to the context of artistic creation, especially performing arts. Text isn't really an appropriate input model for a lot of things we want to express, like continuous curves, for example. Traditional tool chains aren't really flexible, iteration times are too long, and monitoring your live program execution isn't really a thing. So there's just too much friction, too much that gets in the way. So my approach is to experiment with a non-textual domain-specific programming language that you edit through a structure editor. That programming language is then compiled to a bytecode that's executed by a virtual machine, but since all of the components of that toolchain share some common knowledge of the language, it's possible to make a number of improvements to the user experience compared to a traditional approach. So let me give you an overview of how the system works. Let's say we want to sing a song. I will first define a variable to hold my lyrics. It will be a slice of characters, and let's not get too carried away by smart and profound lyrics. So that will do. Okay, and now I will write for loop with an integer index I. I will loop over all the length of the lyrics. So I here, and I will increment I at the end. And now I can put the lyrics that's at index I. And after each lyric, I can pause for, say, 1 second. So if I hit Command R, I can run that program. And you can see that the lyrics are printing down there. Let's do that again. You can also see that code blocks are highlighted in green when they are executed. And we have a small progress wheel that indicates the time elapsed in the pause instruction. Let's wrap that into a function. So I can define a function, sing, here, and I will call my function here. And maybe I don't want to end the show right away, so I will add a standby instruction, and then I will put the end. Let's run that again. So you can notice that the progress wheel is also displayed at the call site. So even if my function definition is far away, I can still see how my function is progressing. And now we have hit the standby instruction, so the execution is suspended and I have to interact with the standby instruction to resume execution. So I will put my cursor in the standby instruction and hit Control space, and it will resume execution and trigger the end. Okay, let's say that we also want to dance in addition to singing. So I will define some moves here. And here we will maybe make a step, and we will clap, and maybe a little twist. And we will clap again, but louder. I will also define a dance function, and I will do the same kind of for loop. Moves, groups, and I will add a pause here. And I call my dance function here. Let's execute that. So unfortunately, we can see that we first sing and then we dance. So that's not what we wanted. We wanted to sing and dance at the same time. So I can wrap the sing call inside what's called a flow block. Oops, here. And flow block is a block of code that will execute its body in a different task that executes concurrently with the rest of the program. And so let's say we sing more than we dance. I will execute that. We are singing and dancing. We are done dancing, but we are not done singing. And here we are in standby. Okay, so let's trigger the end of the show. And one interesting thing we can do with the flow block is add an attribute that's called tempo editor. And this will give you a tempo curve UI where you can click on points, and you can define a tempo curve. You can move the handles to shape the tempo curve as you see fit. And this will apply a time transformation on all of the timings inside the flow block. So if I run that again, you can see that we are accelerating and we are decelerating again, and we are now approximately at normal speed at the end. Okay, so maybe let's draw that. And we are still on the standby here. Speaking of which, maybe I don't want to be on standby, maybe I want to automatically finish the show once the singing task is finished. So I can do that by taking a future value of the flow. I can wrap flow inside a variable declaration of type future of type void. And instead of the standby instruction, I can just wait on F. So now we are singing and dancing. We are done dancing and we are waiting for the singing to end. And once we are done singing, it triggers the end of the show. A flow block can also compute and return values. So For example, let's say we computed the value 42 and we wanted to return that. So here I get an error because my flow block must return a void value. So I will change that to an int 32. So it type checks. And now I can wrap the weight inside a puts to display the value. So singing and dancing, done dancing, and now we print the return value. Okay, so that's all for now. Obviously, it's quite limited right now. You can't do very much, but I think the basics of the temporal model and the programming language are here. I think the next move is to build a standard library to allow interacting with external devices and to extend the language to have more ways of manually steering the execution besides just the standby instruction. So I will try to keep posting demos of the project as it advances. Until then, take care and goodbye.